This video is section 3.7, and we are going to talk about these other stream manipulators that we can use, and I'm just going to be doing several example programs from our textbook. This code is 3-17, and it is going to use the set precision operator, so it is outputting a double, and notice it's 123.364, so it has 3 decimal places after the number, and number 2 has 2 places after the decimal point number, and then they calculate a quotient, or they divide. So if we execute this just to see what the output's going to look like, and look at what a set precision 5, 4, 3, 2, 1 will do, and notice they are outputting the quotient, which would be the when you divide the two. So the first one has 1, 2, 3, 4, 5, 6 digits, and that's what they talk about when your textbook talked about significant digits. So when you don't use the fixed operator, you just get the number of digits and it doesn't count the decimal point at all. And so that's just showing you have 6 digits, 5 digits, prints 4 digits, 3 digits, 2 digits, 1 digit. So if you don't use the fixed operator, this is the type of output that you might get. Often though, we want to use the fixed operator because we want to control how many decimal places actually print. Like we want them all to print with 3 decimal places or 2 decimal places, etc. The next program is 3-18, and it uses a combination of set precision and set width. So set precision is basically saying I want to print 5 digits and I'm going to print everything in a field width of 8. And that field width of 8 gives them a little bit of space before and after the digits as necessary. And so it looks all nice and neat, lined up, and it's got 5 digits. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now I entered sales data that was less than 100 per day. So let's see what would happen if I entered sales data that is more than 100 a day for some of them. And maybe we have a really good salesman who's printing or has a lot of sales, and then somebody who doesn't have as much, and then our first person really didn't do well. So it should output here as soon as I press enter. And so notice that it is printing everything with just 5 digits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3 digits. I'm not counting the decimal point. So it prints 5 digits. This maybe is not as organized, or it looked fine when I had data that was less than 100, but here it doesn't look as well. Also notice how they did like this dashes right here, so in order to make the table look kind of nice. So this would be what I would expect with some of your output. If you have a table, you should have a title for the table, and then you should have a separator, and then you have different rows, etc. In the previous example, we saw that we really want to have some control over how many decimal places are printed after the number. For example, if we're dealing with money. This example is going to show us the other, they're called stream manipulators, and we are looking at the set. We looked at set precision, and we're going to look at fixed and show point, and maybe the left and right. And so the first one outputs the number with no formatting at all, just see out X with no formatting. The next one is going to output it with a show point, the next one with a set precision, and lastly with a fixed. And please notice when it says set precision parens 2. So let's take a look at that output. So when it has no output at all, it's a double data type, and so it just prints a 6. Now when we're working with numbers and we're working with programs, we might recognize that as just an integer when it's a double, so oftentimes we do want it to print with the decimals. If I just say show point, it prints a decimal point, and its default is to show 2, 4, 5 places after the decimal point. When I say a default, that means we haven't told it to do anything else besides show point. So then it defaults and shows 6, and it shows a decimal point. Lastly, but the next two are going to show a set precision of 2. Now the set precision of 2, remember, does 2 significant digits, so I have 1, 2 significant digits. Now the next line is the one that's kind of important, because if I say fixed in addition to saying set precision 2 and a show point, all of these carry through, and it's going to show a number that's shows there's decimal point, and it shows a fixed place of 2 decimal places after the 6. So when you do set precision 2 and fixed, it's going to show those 2 decimal places after the number. Program 620 combines almost everything and then adds one new item to our list of stream manipulators. We're going to look at left and right in this one. Okay, so we're outputting strings, which are months, days, which are integers, and temperatures, which are doubles. And so when you output this fixed show point set precision, it will stay on this setting until you change it. And so you only need to do this once. So you only need this line of code in your program once in order to set the fixed decimal points, etc. If you want to change it, the set precision, to something else for an output, then you do need to go in and you would have to then repeat this line of code. But then we have our title for a table, and notice it has left and then right and then set width of different things. Okay, so when we take a look at this, left means left justify, right means right justify. So if we take a look at the table of data, see if I can scroll down and get the table of data and this line all on the same thing. Okay, so when it's outputting this, it's going to left justify the month, and that's a string, and it sets aside 12 field width for every single one of the months. So then what that does is it allows then the days to be lined up as well, because these months have like a jagged end here, and so if I didn't tell it to set in a field width of 12, the days would not line up. Okay, if I change, just for example, if I change that set width here to something different. Now remember, the computer's going to override if it needs more space. So if I change that set width on the month to something different, it overrides, and you see how the table of data gets all kind of wonky. Okay, so that's why they set the width to 12 on all of the months, because that's the space that they needed. The next line of code is going to say that we want to right justify the days, which means they line everything up on the right hand side. So the months are left justified, the numbers are right justified, and then it outputs the days and then the high. So if it's an integer, it will not print those decimal points after it. It just prints an integer. But anything that's a decimal point is then going to use that one line of code that we said, fixed show point set precision. So it's only going to show the point and do the precision of 1 in this case if it's a double value. If I decided I wanted to set the precision to 2 and execute, I should get 2 decimal places after on the right hand side, and those values are right justified as well. So this data is right justified and this data here is right justified, which means it lines up along the right hand side. If I were to right justify one of the months, just to show you what that might do, it's then going to print the month right justified in that column. So January will be moved to the right. So now you know that the end of that column is, right there at that marker. But it's not typical for us to do this when we're printing a table of data. So we like to left justify what we would say is the row header, or the row, what each row stands for, and then we would right justify the numbers. And so that gives you kind of the summary of all of those operators that you guys are going to be working with, and this also would show you how to output money. Now some languages actually have you be able to put, like if this was money here, they would have a special formatting, and you could put, it would automatically output a $sign. If you guys ever have to do money, let's pretend those last 2 digits are money, you literally would have to go in and put in a $sign and then put in another operator here. And so if we execute that, we should get the $sign, and now it messed up our justification because it maybe went beyond a width of 9. I'm not sure what it did there. And so we'd have to play around with that to get that to work, but you would literally have to put that $sign in order to get that to work. I'm going to take that out and execute it again, so we're back to where we started from. Okay, that's it on formatting with set precision, show point, fixed,